I think we might not be able to cover all the stuff, but I want to go over quickly the next two sections. Is about like exporting data and creating time-lapse animation. So exporting data is something one way or the other. Eventually, you have to export some data. So earlier we do some zonal statistics. You actually exporting as a CSV. But if you want to export images and feature collection, large amount of data, then you can. This section might be helpful. So always, my recommendation would be, if you need to export data, try not to export like huge amount of data. Usually you do the analysis, aggregate, get some numbers, statistics, and export it. But don't try to export like the raw data. Gigabyte is not going to be very efficient. Or you can export, I think it's unlimited, but you just need to wait. It's just like, think about like, okay, so you want to watch a movie in a theater, it's free. Everyone is rushing to the same theater. You only have the same like capacity. You have to wait. If somebody is already there in front of you, wait for them to finish, and then you can go in. So there's certain number of like concurrent exporting tasks you can do, and try to avoid. You should finish all the computation, and then get some small sections, small results, and then you can pass into other program if you want to. So here I want to quickly show you how you actually export data. And oops, what happened? Let me see here. Is it because what's this? Violation of protocol. I don't know what it is. Let me restart my kernel. So this is where actually Python is so much better than JavaScript, okay? So if you have ever exporting data using JavaScript, exporting hundreds of images, if you use the traditional whatever the Python JavaScript API provide, good luck. Like click the button, run, like, if you remember, I'm not sure how many of you tried it. It's not very clean. Python is just one line of code, it is automated. So I will show you the example here. Let me import the library. And then go back to the export data. I hope it works this time. Okay, yeah. So think about here, I have an image. I want to export this image, but for demonstration, I'm just going to, for example, extract a small subset. So think about here, you can think about this as a global image. I have a country or whatever polygon. I want to export images from within this bounding box, right? So once you have the image and also have the bounding box, there are a couple of ways you can export the data. So you can export data to your Google Drive, or you can export data directly to your local computer. So if there's a function Gmap called export_image, and then give an image, and give me the file name, and what's the resolution you want to export, and also the region is basically the bounding box. So Gmap allows you to export data directly to your local computer, but there's a limitation. So it's only, I think, 32 megabytes or something. But if you have a large image, you can export to Google Drive. So I can just run this one, take a look. It's basically using a get URL, the get download URL, and then this Gmap automatically download the image from the get, the URL. So, and once it's done, on the left side, if I refresh, you see, you should see this one. So this one has been downloaded, right? It's very quick. So if you need like small section of the image, this is the fastest way. So just download the data to your computer. And sometimes the image that you downloaded, the projection, so if you're downloading an image, and then after it's downloaded, or you add the data layer to some desktop.js, and you figure out that, it doesn't align perfectly. There might be 1 or 2 pixels like offset. It happens. So if you really want to be precise, when you export, you can specify the CRS transform and also the CRS. So in that way, basically, it otherwise automatically calculated. Sometimes might be half a pixel or 1 pixel difference, but you can calculate the CRS transform based on the image, just like in here. And then if I export again, that one will be very precise. So usually it's aligned much better. So basically, just keep in mind, After export the data, if it doesn't align with your existing data, that might be because when it's exporting, it's automatically calculating the upper left corner. So sometimes it's not exactly on the pixel upper left, and then it will mess up. So this is one way. Second way is to export data to your Google Drive and just export image to Drive, and then just give you the image, and then the description is what's going to show up on your Earth Engine JavaScript code editor. So export to Google Drive. This line only executed. It doesn't show you the result. So if you want to see whether it's done or not, you need to log into your Google Engine and then log into your account, code editor, and then up on the right, there's a task. So if you see here, you see right now, upper right corner over there, it says lane set. So that's the one that I'm downloading. It's not done yet. Usually for small images, they take a minute or two. So again, if I'm exporting data to your Google Drive, you need to check the status on the JavaScript code editor. If you're exporting directly to a local computer, then you will know when it's done. Okay, so you see, it's over, it's done. Then I can open in Google Drive. It should take you to where, for example, lane set. I've tried it a couple times, so you see a lot of files in here. But this is basically where you export data, either locally or Google Drive. So Google Drive has a much larger limit. If you're exporting to locally, usually you can only export 32 megabytes, so it's pretty tiny. But there's a workaround I can show you later if you really want to do that. So there's one example how to export the data. Oops, where's the? Oh, here. And the next one is exporting image collections. So where is it? Image drive. Oh. Yeah, I didn't provide that one, but anyway. So image collection means if you have a time series images, you have 50 images, you have 100 images, you want to download them, export them to Google Engine. So here I'm giving, for example, this specific location and have some images, USDA 1 meter resolution image, right? So here I have 7 images. I want to export them all at once. So there's a function here, export image collection. So export image is just one image. Export image collection is like just doesn't matter how many images you have, just one line of code. Give me the image collection and tell me where you want to save these images, and also tell me what scale you want, right? So the original image is the 1 meter resolution. You don't necessarily have to export 1 meter. So for this demo, I'm just exporting 10 images. So right, so 7 images, just one. See, it's automatic, it's running. If you're using JavaScript, good luck, click, 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 click. Right? If you have 100 images, you click 100 times. But there's some like a plugin that allows you to automate it, but there's more like a hack rather than. This is officially supported by the Python API, so we can automatically start the task. You see? Now I have 7 images. On the left side, you see that? It's all done, automatic. One line of code. Get whatever data that you need. If you want the large image, there's like export image collection to Drive, so you can do the same thing. But this, you can, for example, export the original resolution. But again, it's supposed to be just, it's done, the total number 7 images. But again, you need to go to the task editor here to see how many images, right? You see, it's popping up, 7 images. Do you have to click the button? No, it's automatic. It's going to start automatically once it's done. So this is the nice thing about Python API is that you can do a lot of automation without having to click those manually. Right? So we talk about image collection. You can also export feature collection. So for vector data, I can do the same thing here. I add, for example, country of Germany. Again, this is usually good for a small feature. If you have very complicated, like median vertices, don't do that. It's not going to work. Because, like I said, if you're exporting data directly to your computer, whether you convert to a data frame or shape file or anything, you need to stay within that limit. Anything large, export to Google Drive. Okay. So the first one here, that's simple, right? So this is a Earth Engine feature collection. So it's the country of Germany. Anyone from Germany? Okay, 1, great. So here, right, you can try out with other country of your own country, right? So here, Germany, I can convert the feature collection directly to a shape file, right? So if you want to download this one as a shape file, just E to SSP, and then it's going to take a couple seconds. It's going to convert it, download it one, and then it's going to show up on your left side on your in here, right? It's done. You see Germany, the shape file. Then you can load it into desktop.js or whatever you want, right? Or you can use the e-export vector. So e-export vector allows you to convert to any vector data format supported by GeoPandas. So it can be shapefile, it can be GeoJSON, it can be anything. I'm still using the shapefile, but it's Germany too. But you can change, for example, to Germany.GeoJSON, okay, or Germany.gpkg, for example. Yeah, let's try, okay? It's dangerous. Let me see if it works. So GPKG, like GeoPandas, GeoPackage. Okay, this one doesn't work, so you see, you know what I'm saying. Only support CSV, GeoJSON, JSON. I think I can add support for that. So essentially, if you can export shapefile, you just convert it to other data format. Or you can just export the shapefile and then use GeoPandas to read it. And you can also E to GeoJSON. So this one doesn't show you the download URL. So this is more direct. So it's turning the feature collection direct to the GeoJSON. So it's like on the fly conversion. So that's why it doesn't show you the download URL. And on the left side here, you just see this one, Germany GeoJSON right here. Double click, you see this one, okay? And all the attributes associated with the feature collection is also being downloaded, okay? Again, I want to point out, usually good for small file. If they're like very complicated at the national scale, don't do it. It's going to crash, okay? Export to Google Drive. And vector data exporting is a little bit slower, I think, than raster. And you can also convert, for example, to CSV. So if you have vector data, you want to just get the attribute table, you don't need the shape. So sometimes, for example, you have like a country feature collection, it's very complicated, the shape, but you only write attribute table. Then you can just use the E to CSV, and then, for example, Germany, convert to Germany, and then you should have this one. It will be just one line of code, just the attribute table, no shape, okay? And this would be nice if you, just like what I mentioned earlier, you do some zonal statistics, you get a feature collection, and then you do a bunch of operations with other feature collection, you end up with a new feature collection, and you just want the result of the feature collection, then you can just E to CSV, or E to DF, right? If you just want a pandas data frame, then you just E to data frame. So this basically allows you to convert data either from locally to the cloud, or from the cloud to local, or from cloud to Google Drive, and then from Google Drive to your computer, or from Google Cloud Earth Engine to Google Cloud Storage, and from Cloud Storage to your computer. So there are multiple ways you can get the data out from there. So next exercise, we don't have time because we only have 27 minutes. I want to show you other stuff. So here, this is an example I want to show you, right? So think about you have data for the global scale, and then you want to export the image. You cannot export the whole piece because this image, like many gigabytes, it's going to time out. You cannot export, definitely cannot export to locally. You can export to Google Drive, but it's going to take you a while. And it would be nice if you can get like small piece, like just like an end, like each one do a small piece. It's doable. So here I'm creating a FreeSNAP, and then use the FreeSNAP to download all the images small by piece, and then you can mosaic them offline. So this is just like, for example, I'm creating a map. I'm creating, getting this mounting box, and then if you want to do it, so here, this is what it looks like. So I'm going to create a FreeSNAP, and then I'm going to download image in which FreeSNAP. And you can download all image style into the periodic downloading. So let me show you here, Control-C, Control-V. There are two ways you can download. So this one can download more than just 32 megabytes. So for example here, this is my area. I subdivide it into smaller tiles, and then I can download based on each tile, okay? So I'm going to show you the answer key here. It's pretty simple, Control-C. So this is the function that you can use to get the data out quickly. Where is it? Here. Control-V. oops. Right. So gmap.download image tiles. So basically, give me a big image and give me a feature collection, basically the grid, kind of like zonal statistics. Give an image, give me a feature collection, and then just tell me where you want to download the data, what's the resolution, what's the coordinate system, and take a look. So this one, how many images in here? How many small polygon? 1, 2, 3, 4, 7, 28, right? 28 images. So I'm downloading, you can explain it to the global scale, right? Just like a coordinate grid. And then just run it. Like, how nice, automated. Like, one line code, download whatever images you like, and it's downloaded as like in here, and then name alphabetically, 0 to all the way, right? So you get 28 images. This one you can download more than 32 megabytes. So you can basically kind of use it as a workaround if you want to. So now you know how to download large images from Google Engine, right? One line. Right, give an image, I generate a fishnet or a feature collection or whatever, and then just use download image tiles, and then you can get all the results. It might take a couple seconds. So this is one way. The second way is even better, is doing the parallel downloading. This one is more like sequential. Now finish the first one, go to the next one. And if you really want, like if you have hundreds of like images you want to download, this one is a little bit faster. But sometimes it might not work because this is using the multi-threading. So I'm going to copy here just to show you what it looks like. So this one is download image underscore parallel. So this one is by default, you can, I'm not sure how many, but use all the parameters are the same except that it's parallel downloading rather than sequential. So let me execute this one. It might not work on Windows. I forgot that whether it works on Windows, but it should work on Mac. You see, this is a big difference. It's not like you see 6, 4, 5. Like it's basically simultaneously, and it's already done, right? You see, so quick, rather than the sequential. So these are two functions you can try it out, and with this, you can download any data, any kind of format, locally directly without go through Google Drive. But if you have really large data set, I would still recommend just go to Google Drive or save the data to Google Cloud Storage. Yes? Yeah, good question. So once the data is out, it has nothing to do with Google Engine, so you cannot use Google anymore. But there's a function in Gmap that allows you to mosaic them. I forgot. Whether it's Gmap or leaf map, so I can do a Gmap, maybe see here, Mos or something. Not Mos, mosaic. Yeah, mosaic. So here I'm run this one and then Shift tab, so you can pass in just a list of images. So here, and then you can provide the output on how you want to do that. So here would be, right, earlier I export all the images as tiles. So then I was just doing here, just tiles, passing the directory. Again, this is on the fly, so I'm not sure if it works or not, but we figured out. So mosaic, okay, all the images come from this directory, and the output I wanted to save it as Mos.tif. I don't know. Yeah, it's working. Yeah, Mos raster. And is it still running? Oh, it's already done. So then I come back to here. Should be one like Mos. Yeah, it's there. Right, so we can mosaic. So under the hood is using GDAL to mosaic them. There's also function you can split. So if you like, if you want to split an image, for example here, I think it's called split raster or something. I forgot. There's so many functions, so I don't know the name. I don't remember the name. Should be gmap.split. Yeah, it doesn't show up. P. Yeah, if no, it's divmap. So divmap has probably have more functionality for dealing with local data. So I can import leafmap and then leafmap.split. Yeah, split raster. So you can split the raster into like different rows and columns. Anyways, and that's not the focus. Right? So yes.
Can you also split it within, the bands? Like suppose I have 78 bands.
Huh?
Suppose I have data of 78 bands.
Huh?
And I'm not able to download it at one go.
Uh-huh.
So can I just make a bunch of 10 images and then 10 bands and then?
Yeah, you can do that. So you can create a map function, just do grouping, so you can create multiple image collections. So and then just export image. For example, you select the first 10 bands, and then export the data, and then you do the next one. So it's certainly doable, yeah. But you just need to write the looping. So whether the for loop or is a map function, something like that. Okay, so we have 20 more minutes. I know very, very quickly. So last section is just for fun, right? Creating time-lapse animations. So you probably have seen a lot of those on the social media. Now I'm going to show you how you can create by yourself. 20 seconds, any location, any temporal frequency, any image, any feature collection. It's so easy, okay? So let's look at this one. I'm just going to show you what it is, right? So for example, this is the area that I'm interested in. This morning I showed you how to get the time series, for example, for San Francisco for all the entire image collection for that area. But now what I want is I want the time series. So Gmap has a function that makes it so much easier for you to construct a time series for any location, using any satellite sensor. So here, look at this function, gmap.naip time series. Okay, so nap imagery. And then just passing the ROI is a geometry. So basically it's going here, you can create a map, draw any rectangle anywhere you like, and then you can just one line call construct, okay, I want the Landsat time series, I want the Sentinel-2 time series, I want the USDA nap imagery, I want the MODIS. One line of code, okay? There's no filtering, nothing, just tell me how frequent you want. So in here, I'm gonna say, okay, I want this area, I want the start year from 2009 and end year 2022. RGBA means you want the first color composite, you want to have 4 bands. So take a look, just one line, and then you can see what kind of days in there, right? So this area has images since from 2009, almost every year until 2022. And then you can add all the data layer to the map. So this one is using a for loop, okay? So try not to use for loop unless you have to add the data layer of them automatically. So take a look. So this one right now is I'm creating the time series. And then you see I have all the data layers, right? All the way from 2009. You might have to turn off all the data layer, but you certainly have all the layer here. So let me turn it off in this one, right? 2019, or maybe start from 2001, right? And 2010, 2022, 24, right? You name it. So basically, nap imagery for the entire US. You can do this for anywhere, okay? It doesn't matter. It's just a bounding box of polygon, and then you can create a time series. Just one line of code. You don't have to filter. You don't need to figure out what year it has. It's basically automatic. And with that, now you can create a time-lapse animation. So this one is using gmap.nap time-lapse. Again, the same ROI, and then the GIF animation. What kind of spectral bands do you want? There's tons of parameters in here. We don't have time to cover all of this, but this is basically the one line shortcut to get time-lapse animation. This is for USDA name imagery, but I'll show you others, right? So take a look at it here. Just simply draw a rectangle somewhere and specify the temporal frequency, and take a look, right? How nice. Just one line of code, you can do it anywhere, right? So this you can show, for example, the water changes. If you like, okay, I want somewhere else, okay, you can certainly do that. So I can go back to here. I can maybe just show the base map data layer, right? They say, I'm done, okay. So now, for example, USDA name imagery is the highest resolution available for the US. It's free. Every 2 to 3 years, you have coverage. But that area is outlier. You have almost every year. But if you're interested, for example, okay, I'm studying surface water. I'm really interested in looking at how the water changes, like in this area. Okay, so come back to here, simple. Just draw a rectangle. Okay, let's say, okay, I want to study this one. I want to see how it changes. Right now, using the 1 meter, right? And then just one. You see? Take a look. All the data layer have been added, right? And just run this one again. You should get the animation, right? So can you get it for your hometown? If you're in the US, right? It's as simple as that. So now you have this. Of course, this is like every couple of years, so sometimes you don't really see the changes. But there are a lot more examples that are more interesting. So next one is Landsat. This one is at the global scale, so you can do that for anywhere. Again, just create a map, and then just simply draw a rectangle somewhere on the map you like. I'm just going to use the default bounding box. Okay, so here, where's this? Anyone know? This is in Peru. Okay, anyone from Peru? No one? Okay, I'm so sad. Anyway, so here, I get the bounding box, and then again, just one line of code, gmap.length set timelapse, just passing the ROI, where you want to save it, the start year 1984, end year 2022, you can 2023, it's up to you. And the start date is like, you can use the image for the whole year, or you can use image for the summer. For example, summer you'll be, let's say June 1st, and then maybe October 1st, something like that. You can narrow down the specific area you want. And how you want to, the bank combination you want to use, okay, short wave, near infrared, and red, how many frames per second, right? So the larger the number, the faster of the animation. And the title, the progress bar, everything, save as MP4. So like 20 seconds, you get an animation for anywhere around the globe. Again, you can try it out. See how nice, right? This without Google Sensing, before Google Sensing, this takes you hours, sometimes weeks. Yeah, it depends on the area, right? You have to download the data, you need to create the mosaic them, and need to remove the cloud, and need to do it by year, right? There are hundreds of images actually in here. This looks simple, but under the hood, this is like, you can guarantee you hundreds of images, because from length 5, 6, length 7, 8, 9, composite and remove the cloud, and then show you, and then once it's downloaded, the Gmap adds all the label and the progress bar, something like that, right? So now it's so easy, you can do it for anywhere. So I'm going to show a couple more interesting examples. This one is, for example, the famous Las Vegas, right? But again, you can just draw the rectangle somewhere on the map and then try it out. You'll be amazed like how fast it is. Okay, all done. So like Las Vegas. And I think this one is Hong Kong Airport. Right. So the data is not limited to just annually. You can do it by quarter. So maybe I can show you another example. Right. There's a parameter that allows you to specify the temporal frequency. So by default, it's annual. It's like by year. So 1984, 1985, all the way. But you can. But if you're doing for a longer time span, you don't want to use monthly. Right? How cool is this? Right, no, basically like one line of code, just specify where you want, and then just call this function. Right, you can see the airport constructed like around 1995, and you get it. So here I'm going to quickly show you. There's a parameter I think it's called frequency. Here, so by default it's year. So if you're doing some like annual, monthly, or seasonal changes, you want to see the seasonal changes. Just provide a parameter frequency equal to month or to quarter. And then, but you need to narrow down to a smaller year range. Otherwise, right, every year you have 12 frame, and then you do it like 30 years. You're going to have a lot. It's going to exceed the memory. Yes.
Yeah, so we drew some polygons here. But is there a limit on how big the polygon can be? I mean, how can we get a feel on when the polygon is too big and it would crash?
Yeah, it will tell you. If it is too big, it will tell you. It's going to, Google Sense is not allowing to download the imagery. So again, I can. Yeah, I'm running another list here. I can do it on the fly, right? So I can do it here. How about maybe this one? And then I can make it zoom out. If it's too big, lens size sometimes not good for that. You want to see the detail. If it's like too, the area is too big, you might not see a lot of changes because this is just like no detail you can see. But in here, for example, this one is a little bit larger, right? And then I need to change this one to map.user ROI. And so this one maybe whatever name, okay? And then I run it. If it doesn't work, it's going to show you. Or you can click this URL. If the URL is like error, that means it's too big. But here, you just need to wait. So the larger the area, the longer time it's going to take because the more images being involved in the computation. So it might take you, usually it should be up to like 30, 40 seconds. You see, it's done. And then after it's downloaded, it's adding all the label, upper left corner, and also the scale bar here. This is not Hong Kong, but you can customize it, but right, anywhere. So now you can go online, you can do it by year, you can do it, or maybe try it by month. I'm going to show you here, frequency. But let's say image is like every 2 weeks you get one image. So by month, you're having a risk of a lot of cloud. So you might end up with lots of a dark area if you remove the cloud. So you don't, probably quarter, I mean, it's better, but I can certainly try. So frequency equal to, I think, months, okay? But certainly I need to limit it, okay? So probably maybe from 2000, like only 2 years, 24 time stamp, they're probably a little bit better. But if you use monthly, usually the quality will not that good because you might have, oh, you see, it's too much. You can say the pixel blah 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 is exceed the limit. So maybe I can do like 2021. You see, it's still too big. So you need to narrow down the smaller one because you are requesting too much data. Oh, 2000? Oh, sorry. This is way too much. So I'm to 2020. So hopefully this will work. Okay, 2020 to 2021. Yeah, this one works. Is it the same? Okay. Yeah, either narrow down the year or narrow down the start and end date. Okay? Yeah, so this is like not surprising. Because if you're doing monthly, you might have cloud, then it's going to remove the cloud, end up with all lots of the dark area. But if it is very cloud-free, then you are welcome to use monthly. And then you will see the label, right? 2020, like you're going to, the label is the month. Yes, questions? It depends on the area, depends on how many images are involved. So the larger the area, the more images being involved, and also depends on the temporal frequency. So if you use it like monthly, large area, it's not going to work. Okay. All right. So this is lane set, right? Global scale. Try it out for any way you like, and then create some animation. So next time, if you see somebody post on social media, cool stuff. Yeah, I can do that as well. Just one line of code. All right, so this is lane set. You can say, okay, I can do Sentinel too. You cannot. You only know how to deal with lane set. So I can do Sentinel 2 here. For example, the same idea. The function pretty much the same. Given an area, and then you automatically use the entire Sentinel 2 archive and create the animation. This one is a little bit better than the lane set because it's 10-meter resolution. So it might be a little bit better. But yeah, it's pretty much the same idea. It's filtering all the data, creating the time series, and then download it as a GIF animation. But you can also use the, if you want the original data, just replace this one. gmap.sentinel2, replace time-lapse with time series. Then you will create an image collection. Then you can do computation. But same idea here, right? Cool. But this is at a shorter time span, usually from 2015. You can do modis, right? There's a couple of the images that you can do. So here's one here I'm using, for example, interested in studying vegetation in Africa, right? Modis, NDVI time lapse, and give him a ROI, where you want to download it, which satellite, what's the date. How cool is this? How long did it take you to create this one using the conventional remote sensing? Download the data. How do I visualize the color? How do I put it all together? And this is like hours work. Now 30 seconds. It can be vegetation. It can be ocean color. It can be anything. So think about here. You can. Here I show you some of the lane set Sentinel, but there's a generic function called create time lapse. I don't show you the example here, but you can, yeah, this is ocean temperature, right? Cool. And there's also a color bar, even better, right? You can also add a color bar to the vegetation if you want to. Here, right, you can add the color bar, and then you can also overlay the continents. So this one, the yellow color shows the country boundary, right? So you can not only just the raw image, you can add vector data on top of that. You can say country boundary, state boundary. And you see, just like continents, I want the continental boundary on top of the, and then I want the color to be yellow, and also the opacity, right? So a lot of things. Under the hood, this is hundreds of lines of code, okay? So, but it's condensed to just one line. And this is like for specific satellite, but if you want to be generic, think about if you have an image collection, you want to create a simple animation, just call this function. So it's API reference, and then I think it's under the time lapse. So there's a generic one called create. So gmap.create time lapse. Just call this function, passing an image collection, and then the start, the day, and then the frequency. It will automatically do all the processing for you. So you don't have to worry about, okay, how many images per month, per year, whatever. So if you want this one, it's very complicated. There are tons of variables. But this one is for the functions that, for the satellites that's not available in Google Sensing, that you cannot just use Landsat underscore timelapse or Sentinel-2, because those are the common ones that I already added, okay? And we have 5 more minutes, so we're going to go through the last couple here. For example, the GHOST data set. This one is good for weather and climate monitoring because it has images every 5 minutes. Landsat is only like every 2 weeks, or if you with other multi-sensors. But this is nice, right? You can create, I'm sure you have seen this one on the internet, right? During the Tonga volcanic eruption, right? One line of code, pretty much like goes time lapse and specify the area, output, when it does it happen, how many times, how many frames per second. Now you create, right? You can do it for anywhere. So it can be volcano, it can be hurricane, it can be anything. It can be anything that can be captured by this. It can be wildfire. But this one is a little bit tricky. You need to be very precise about where's the location and what's the time spent, because this one is a lot more data. So every 5 minutes, it's like the data set is involved is a lot. So you can easily get like memory timeout. You just need to narrow it down and then figure out the time spent. Eventually you will get it, right? So I'm showing you, for example, the volcanic eruption, but there's hurricanes, or right? How about this one, right? Hurricanes. How cool is this? Right? It's using a GHOST satellite. You can those you see on TV, social media. Now you can create. So next time, is there any like major disaster? People posting, okay, I can create some as well, and then you can post on social media, right? As simple as that. All you need is just the area, the bounding box. I know the satellite you're going to use, okay? And besides just creating animation, you can also use that, for example, wildfire. So if you're working on wildfire, there's a wildfire data product in Go. So you can actually not just monitoring the spreading of the wildfire, you can also extract the boundary. And you can have some like data layer on top of the original data. So it's come up very, very quickly. So take a look at this, right? Wildfire, and then you see the pink boundary. That's actually where the data product already have, right? So I can show you how it is spreading. So you can build multiple data layers on top of it. Very simple. Okay, so try it out. And so right now you can go say, okay, if you any animation, I can create for you. Oh, what satellite do you want? Or Landsat, yeah, one piece of cake, right? One line of code. If you any other satellite not available there, and just create time lapse and then you get it. Okay, so this is how you can do the coding. And the next one I will show you is, okay, even better, no coding. Okay, so take a look at this one, Gmap domain. This is supposed to be an exercise, but I'm going to show you anyway right now. So take a look at this. By default, if you just create a map, so let me just come on out this one, right? Just create an empty map, and then let's say, okay, I want to study, for example, I want to look at this area. I want the time-lapse animation for this area. It's simple, yeah. So just, okay, I want this one. Let me draw a rectangle, and then just click the toolbar, and the first row, the last column, click that, okay? And now it's going to show you the base map, and that's it, okay? Create time-lapse, that's it. Even better, right? No coding. Of course, you can adjust the parameters here, start year, the end year. Right now, I have Landsat, but I mean, I can add more. But the coding is more flexible because not all the satellites share the same parameters, so I have to change the interface. Depends. It's a lot more work, but I'm just like, at least for those users, they don't want to do coding. Yeah, this is a lazy way you can do it. And it's computing, it's the same thing. Under the hood is calling the Landsat timelapse function. It should take like 20, 30 seconds, and then you should see this one. And then you can have the parameter, you can change the color bar, you can change the end year, or you can even calculate the vegetation or the water index, extract vegetation and water automatically. I hope it works. Sometimes you might get stuck, you just restart. And yeah, I hope it works. And yeah, so that's what I want to show you for all the sections. I think we are right on time. It's 1 minute. And the last section here is optional. I guess we will not have time to cover. But this one is when you want to turn your stuff into an interactive web app. So for example, if you develop some cool stuff and you want other people to actually use that, so that they don't need to have a Google Sensing account, it's also possible. Okay, it's done. So see, this one is even nice because it's over there on top of the map, right? I can zoom in, I can zoom out. How cool is this? It's not very clear. You just remove the layer, right? Just like magic. right? You can go to any other location, draw a rectangle, create, right? So now you see there's no secret. It's super easy. And the last one, again, 30 seconds. You can go to the exercise, go to the link. This one shows you what it looks like. So this is the one, for example, I developed based on open source packages, Gmap. And I used familiar with this one. I showed you earlier this morning, right? So now this one, if you take a look at here, anyone can go online. You can send to anyone. They don't need to have a Google Sensing account. They can do it pretty much very easily, right? And you can zoom in, you can zoom out. Don't click the link because too many people, you might crash. Because I think Google Sensing has like concurrent limit connections. Like I don't know how many, but if I have some apps that are very popular, I have to restart the app because like it crashed. But at least you see here, I can click the inspect. You see, sometimes it. Anyway, this is not something very scalable, but it's certainly an option that if you want to, you can turn your stuff into a web app. Let me see if it works. If it doesn't, it's fine. Okay, it works. Right on the right here, you see. I can maximize. These are all the Google Sensing data layer that we show you at the beginning, but now it's on web app. It's based on Python, so it's so super easy. I can click. I can do this. It might be a little bit slow. If any of you are clicking it, it's contributing to the slowness. So in the future, if Google Sensing has official support to for Python, that would be better. But for now, if you want to develop app like JavaScript has the Earth Engine app, Python has no equivalent. But at least this is something alternative. If you really want to try out, you can check out my Hugging Face. I have tons of web app available here that allows you to create all kind of stuff. For example, Timelapse, right? Like the one I showed you earlier. But this is using a Streamlit or using Solaro, right? You can create an app that allows people to interact, create animation or whatever without coding. And if you want to try it out, it's very simple. So if you go to this one here, all you need is just 2 minutes. Your app will be running, and then you can send to anyone. So if I go back to this one here, the example that I showed you earlier is actually, I think it's a Solaro Gmap. So, okay, you see, it's timing out. But let me reboot the one here. So what you can do is to go to this web app and then sign up for an account, and then upper right corner there, just click and then duplicate this space. So you're going to duplicate this one to your account. Basically, you're copying my stuff to your account and then become yours. And the only thing you need to do is to add the token, Earth Engine token, to this app because you need to authenticate using your Google Sensing. So click the settings. After you duplicate, click the settings. And then if you scroll down, there's a so-called secrets. So where is it? Secret? Yeah, this one here. So new secret. And then just type Earth Engine token. There's instruction on the web app here. I can show you. I will already over time, but I want to show you where, if you really want to make your stuff accessible. So click this one. Yeah, it may take some time to load up. And this token is, I showed you earlier at the beginning, the credentials file on your computer. Depends on operating system. So here is under my user account, and then where is it? .config Earth Engine. Open this file, copy all the content, entire content, and then come back to here. Just paste your value here, and then save. Restart in your web app. When people go to your app, you will automatically authenticate. So that otherwise you're going to pop out like, okay, enter the token. It's not going to work because users don't have that account. But this is a little bit more advanced, but certainly it's possible. And like I said, you can, I'm going to show here the file. And then the README. It has all the step-by-step how you can do that. We don't have time to go through that, but certainly it's possible. You can try it out. And it's bi-directional. So user can click on the map, get the data, get a pixel value, whatever, and you can do all kind of interactive stuff. So, and one last thing I can show you here, I think it's one last one, segment geospatial, for example. This one integrate, for example, you can do Gmap, you can do diff map, Mapbox, like you can do all kind of cool stuff. And then you can zoom in, you can zoom out, for example, Mapbox. So basically, you can turn those applications. Oops, this is a bit too small. It's a little bit buggy, but you see the idea. you can use Python to develop web app, and then just you can display, you can make accessible to anyone around the globe, and they don't have to have an account, right? So you can do this, you can zoom in, you can zoom out, right? Pretty cool. And no JavaScript is needed. I'm not a JavaScript user, but I can still create some of the web app, showcase some functionality. Anyway, so this one to show you. I know it's a lot to digest, but everything is freely available on the web page, and you get access to all the information. You can welcome to, if you have questions, you can go to the GitHub repo, ask questions, or you can email me. I'm happy to talk with you. And thank you very much. I hope you at least learned something new out of this. And like I said, this is a very basic. There are a lot more advanced stuff that we don't have time to cover, but you can check out the book. There are a lot more content available. And yeah, so this is just like give you the foundation introduction to what you can do, but it's up to your imagination what you want to do. And there are tons of things you can do. And I would love to hear what you are building and showcasing, or you can tag me on social media that you use this to build that. I'm happy to help you promote your data products or your research. Thank you very much. Yeah. Any questions? Yes?
In JavaScript, there is MapReduce.
Yeah?
In Python, do you have MapReduce as well?
MapReduce?
MapReduce function.
JavaScript is, I'm not familiar with that. I know the map, but MapReduce, I'm not familiar with that. So what do you want to do with the?
It's parallel computing.
Yeah, it's the map function. So it's the map function. So basically, a lot of things that we did, I mean, under the hood, many of those use the map function. So for example, when I create a lane set timelapse animation, it's actually using the map function. That's why it's doing parallel processing. So I'm creating the list of years, and then based on the year, I create a cloud-free mosaic for that year, for another year. So actually, it's already under the hood is parallel computing, but I just didn't show it. Of course, you can welcome to, for example, I can quickly show you here time lapse, right? So they say lane set time series. So if I click this function, you scroll down, you see the source code. Under the hood, this is like 100 lines of code, and it's actually using a map function. I think somewhere you have the function and then map, right? So this is all the parallel processing, combine multi-sensors together. But for only if you want to dig into the source code, you can try it out. So like just one simple lane set time series, I don't know how many lines of code. It's not like easy to make it like generalized so that you can apply anywhere. And it's the same thing for any other collections. So even, for example, create time series, right? So this one is more generic. It works for any image collection, any temporal frequency. And you can see how I deal with that internally, how to build the collection, and eventually how I use the map function to create images for multiple years or multiple months or whatever you like. Does that answer your questions? Thank you. Any other questions? Yes? So yeah, complex one, you can simplify like geometry, but yeah, big vector data is not like efficient. So usually, if you want to do computation, you can simplify. For example, you just use a bounding box, or you can simplify some of the vertices and then use it to do computation. But if you have to export the data, sometimes might be convert to raster, and then export raster might be faster than exporting the vector data, because the more vertices you have, the slower it's going to be. Any other questions? Yeah, we are already over time for 9 minutes, so I don't want to keep everyone here, but I will still be here. If you have any questions, you can talk to me, or you can email me. Yeah, you can reach out to me even after the workshop. So yeah, just let me know if you find it useful. If you use it, let me know. I'm happy to know how the community is doing. And also, we welcome contributions. So if you know how to do coding, you want to contribute, everything is open source. Just look at the source code, submit a pull request, or fix the typo, or ask questions. Ask questions is a contribution. So if you see, I can quickly show you here. For example, if you go to the GitHub repository, everything is in here. So one way you can do, I would recommend, if you have questions specific to GMap, just come here. If there's a question, there's a Q&A here, discussion. So you can ask questions, just new discussion, create an account, and then you can ask the question. You see all the green check mark. That's what I want to see every day before I go to sleep. Like, make sure questions are makes the question are all answer. So you can learn from there, you can still see other people. But if you find a bug, for example, something is not working, it's throwing an error, then you create an issue here and just describe how we reproduce, what source code you use, what error, and then give a screenshot or something, give detail. And I will usually get back to you within 24 hours. And then the problem might be fixed like within a couple hours. Sometimes it may take longer, but usually it should be pretty quick. So you see like 500 to 25. So we are basically evolving very, very quickly. And if you're really good, you know how to submit a pull request, you know how to fix things, you can create a new pull request, and then we can review it, you can merge easily. So if you have no idea how this all works, you can check out, I think, my YouTube channel. So here even it's on the top page. I have a whole course teach students how actually you to build package and how you contribute, how you develop, how you publish package to PyPI. The whole course is here, and they also data management, PostGIS, other stuff. But this one is like all the practical tools, how you create a package, how you improve, how you publish, how you like. So if you really want to create some packages like Gmap, you can check out those videos. It's all free and up there. So if you have any questions, let me know. I'm by no means a programmer or computer science by training. I just learn all the stuff by myself. When I have to teach, I have to learn it. So not all the source code are super efficient. So you're very welcome to look at the source code and improve it, make it better. So that's what I want to see, is to hopefully more people will contribute to the package. And then once you contribute, eventually you're going to see as a contributor. Right? So right now we have 47. Our goal is to double it next year. Okay, see if you contribute like one pull request, you'll be there. And this is one. So if you really want like other packages, I just want like plug here. So for example, leafmap.org. And so if you go to leafmap, or you can check out like just Google Open Geospatial Solutions. So these are all the packages that are developed and maintained. So you're welcome to check out, like, if you, besides Google Sensing, if there's anything you like, you can find out some of the packages. There are a lot more in there. So Gmap is only a small section of the packages that I developed. But yeah, we welcome contribution. So this is how we make better. So if you ask questions, report a bug, you improve, and it will release a new version, you can use it, and it's keep improving. So it's better than you rely on commercial software that you have to contact the customer service, wait for a couple of weeks to get back, and then you say, oh, how about try this, how about try that? It doesn't fix the problem. We do fix the problem. So if it happens, we fix it, and it gets better. So anyway, so that's what I want to share with you. Again, hope you learned something new. I'll be happy to chat with you if you have any questions. Okay, enjoy your dinner. Yeah.